Alright, so a couple of videos ago, we filled in the unit circle, talked about how to remember how to fill in all these angles and points here and tips and tricks for remembering them. And then in the video after that, we talked about how the unit circle relates to trig. So remember, if we have a point on the unit circle, then the cosine of the corresponding angle, or the angle associated with that point, is the cosine is the x-coordinate and the sine is the y-coordinate. So it's very important to keep in mind. Now what we want to do is talk about the signs, SIG and signs of the trig functions in each quadrant here. So we have an xy plane. This here is quadrant 1, right? Quadrant 1. And this is quadrant 2. So remember, the quadrants are usually denoted with capital Roman numerals. This here is quadrant 3. And this is quadrant 4. Okay. So let's forget about circles and things like that for a second here. So if we're in quadrant 1, what are the signs, SIG and signs of the x and y coordinates? Well, if you're in quadrant 1, your x coordinate is positive and your y coordinate is also positive, right? What if you're in quadrant 2? Your x coordinate is negative, right, and your y coordinate is positive. So like, for example, the point -4, 5, somewhere up here, right, or wherever. But it's somewhere in the second quadrant. So negative x coordinate, positive y coordinate. What if you're in the third quadrant? Well, then you have negative x coordinates and negative y coordinates. So that's negative, negative. What if you're in the fourth quadrant? Well, then you have positive x coordinates and negative y coordinates, because you got to go to the right and then down. Okay, so that's in the positive x direction and then the negative y direction. So that's positive x coordinate, negative y coordinate. Okay. So that's really just kind of like a pre-calculus review, and it's kind of like one of the basics of graphing. So in the first quadrant, all the coordinates are positive. In the second quadrant, it's negative, positive. In the third quadrant, both coordinates are negative. And in the fourth quadrant, it's positive, negative. Okay? So how does that relate to trig? What's so important about that? What's so special about that? Well, remember what we said in the previous video is that if we have a point on the unit circle, cosine of theta, if we have a point on the unit circle and we have an angle theta associated with that point, then cosine of theta is the x-coordinate, sine of theta is the y-coordinate. Okay? So since cosine of theta is the same as the x-coordinate, then if we're in quadrant 1, cosine of theta is positive. Since sine of theta is the same thing as the y-coordinate, then if we're in quadrant 1, sine of theta is also positive. Okay, so in other words, here, cosine of theta is positive and sine of theta is positive also. So cosine of theta is positive and sine of theta is also positive. Okay. What if we're in the second quadrant? Well, still, even though we're in the second quadrant, cosine of theta is still the x-coordinate. So no matter where we are in the second quadrant, the x-coordinate is negative. Therefore, cosine of theta must be negative. Okay, because remember, cosine of theta is the x-coordinate if the point is on the unit circle. Likewise, sine of theta is still the y-coordinate, so sine of theta is positive. Okay? What if we're in the third quadrant? Well, then everything's just negative. So the x-coordinate is negative, which means cosine of theta is negative. And the y-coordinate is negative, which means, so let's zoom in a little bit here. The y-coordinate is also negative, so that means sine of theta, since sine is the y-coordinate, then sine of theta is negative. Okay. Now what about in the fourth quadrant? Well, cosine is still the x-coordinate, so cosine of theta is positive, and the sine of theta now is still negative. Okay. So this looks like kind of a mess, but we're going to simplify it a little bit. So that's good for cosines and sines. What about all the other trig functions? Well, once we know the signs, the SIG and signs of these two trig functions, we can get the SIG and signs for all the other four. Okay, so all we really have to remember is these two here in each quadrant. But there is kind of a little trick for that. So in the first quadrant, everything's positive, right? Cosine and sine are positive, therefore, what about the other four? So tangent of theta, remember tangent of theta is sine over cosine, right? Sine over cosine. What about cosecant of theta? Cosecant of theta is 1 over sine of theta. Secant of theta is 1 over the cosine of theta. And cotangent of theta is 1 over the tangent of theta. Okay. So what does this tell us? Well, this tells us that if the sine of theta is positive, what is the cosecant? it must also be positive because you take 1 divided by a positive number. Okay, so 1 divided by a positive number is just another positive number. What about the secant and the cosine? How do they relate to each other? Well, the same thing. If the cosine is positive, then the secant must also be positive because you got 1, a positive number, divided by another positive number. Okay, what if the cosine is negative? Then you have 1 divided by a negative number, which means the secant is negative. Same thing up here. If the sine of theta is negative, then 1 divided by a negative number is another negative number. Okay? So in other words, the sine of theta and the cosecant of theta, they're either both positive or both negative. Okay? They're both positive and negative together. The cosine of theta and the secant of theta, they're either both positive or both negative. Okay? So they have the same SIGN sign as each other. Same thing with the tangent and the cotangent. Okay? If the tangent is positive, then 1 divided by positive is positive. Okay? So these guys are either positive together, or 1 divided by negative is just another negative number. So they're either positive together or negative together. Okay? So sine and cosecant have the same SIGN sign. Cosine and secant have the same SIGN sign. Tangent and cotangent have the same SIGN sign. Okay? And tangent, the sine, SIGN sign of tangent is determined by the SIGN sign of the sine and cosine functions. Okay, so too many signs here. Okay, so if we're in the first quadrant, cosine is positive and sine is positive. So the tangent is positive divided by positive, which is positive. Cosecant is also positive because that's positive. Secant is positive because that's positive. Cotangent is positive because the tangent is positive. So in other words, everything is positive. So we just say all functions are positive. So we'll call that a capital A. Okay, capital A for all. And then here, what about in the second quadrant? Well, the sine of theta is positive. Okay, so that's really all we want to remember is that the sine of theta is positive. So if the sine of theta is positive, what else is positive? Well, we know cosine is negative here. So if the sine of theta is positive, what about the tangent? Well, tangent is positive divided by negative, so the tangent's actually negative. Cosecant is 1 divided by positive, so the cosecant is positive, which we know it ought to be because cosecant of theta and the sine of theta, they're either positive together or negative together. So whatever one of them is, the other one is the same thing, either positive or negative. How about the secant? Well, since the cosine is negative, the secant must also be negative. How about the cotangent? Since the tangent is negative, the cotangent must also be negative. Okay? So really just sine and cosecant are the only positive ones here. But the way we remember that, just remember that the sign is positive. Okay, so capital S for sine. Remember that the sign is positive. And if you remember that only the sine is positive, then also just the cosecant is positive. So really only those two are positive in the second quadrant. Okay. What about the third quadrant? Well, they're both, cosine and sine are both negative. So since cosine is negative, secant is necessarily negative. Since sine is also negative, cosecant is also necessarily negative. 1 divided by a negative number is a negative number. What about tangent? Well, negative number divided by a negative number is a positive number. Okay, negative divided by negative is positive. So tangent is actually positive. Since tangent is positive in the third quadrant, then cotangent is also positive because you have 1 divided by a positive number. Okay? So in the third quadrant, only tangent and cotangent are positive, but the way we remember that is with a capital T for tangent, and know that since tangent is positive, cotangent must also be positive because they're reciprocals of each other. All right, and then what about in the fourth quadrant? Cosine is positive and sine is negative. Okay, sine of theta is negative. So since the cosine is positive, then the secant must also be positive, but everything else is negative. Okay, because tangent is negative divided by positive, which is negative. Since the sine of theta is negative, then 1 over the sine of theta must also be negative, so cosecant is negative. Secant we just talked about as positive because it's 1 over the cosine. Cosine is positive. And the cotangent is the reciprocal of the tangent, and since the tangent is negative, the cotangent must also be negative. So the only positive ones here in the fourth quadrant are cosine and correspondingly the secant. So here. Okay, so a little mnemonic device that some people like and some people hate is here. So if you go from quadrant 1, 2, 3, 4 like that, you have A, S, T, C. So what some people like to say to help remember that is, so we have all, A for all, and then the S is students, So all students, and then the T is take. So all students take, and then the C is calculus. So all students take calculus. So this might be something you already know about. So ASTC, all trig functions, sine and correspondingly the cosecant, tangent and of course the cotangent with it, and the cosine and of course the secant with it. So all students take calculus, which sadly is not true, but even if you don't have to take calculus, I do recommend that you take it for sure. It's totally awesome. It's great. It's just really great. Definitely take it, whether or not you have to. Anyway, all students take calculus. So if that doesn't really work for you, memorizing this chart is just, it's too much. But what we could do is simplify it a little bit. So let's come over here and just summarize what we talked about in a simpler way to look at. So there's really only a couple things you got to keep in mind. So first of all, you should know which quadrant is which, quadrant 1, 2, 3, 4, but that's kind of like a pre-calculus thing, maybe even before that. But then also just know which coordinates are positive where. So in the first quadrant, know that both coordinates are positive. In the second quadrant, know that the x-coordinate's negative, the y-coordinate's positive. In the third quadrant, they're both negative. In the fourth quadrant, positive x, negative y. And then what you should remember is that cosine of theta corresponds to x. Sine of theta corresponds to y. As long as you keep that in mind, everything else will kind of fall in place. Okay, so if we want to fill in, so let's come over here and just make a separate one. So x-axis, y-axis. Okay, so in quadrant 1, what's positive? All are positive. Okay. In other words, all trig functions are positive. So sine of theta, cosine of theta, tangent, cosecant, secant, and cotangent, they're all positive in quadrant 1. What if we're in quadrant 2? Okay. Well, in quadrant 2, so without even looking at this over here, let's say in quadrant 2, we know only the y-coordinate is positive, which means sine of theta is positive. Okay. And also, if sine of theta is positive, then necessarily the cosecant of theta must be positive, because the cosecant is the reciprocal of the sine, but all the others are negative. Okay. What if we're in quadrant 3? Well, in quadrant 3, both of the coordinates are negative, so that means the tangent must be positive, because tangent then is negative divided by negative. Okay. Since the tangent is positive, then cotangent must also be positive, because these are reciprocals of each other. Okay, so if a number is positive, then its reciprocal is also positive. If a number is negative, then so is its reciprocal. What about quadrant 4? In quadrant 4, only the x-coordinate is positive, so positive x, negative y. So since the x-coordinate is positive, and only the x-coordinate, then that means cosine of theta is positive. And since the cosine is positive, then necessarily the secant is positive. Okay? And everything else is negative here. Okay, so this is a little bit easier to look at here, a little bit easier to digest. But again, I really don't recommend that you memorize this. What I do recommend is that you just understand which coordinates are positive and negative in which quadrant. That's kind of just a pre-calculus thing though, okay? So in the first quadrant, everything's positive. Negative x, positive y, negative x, negative y, positive x, negative y. So just know that that's a pre-calculus thing. But then what you really, really, really need to keep in mind is that cosine of theta is the x-coordinate, sine of theta is the y-coordinate for points on the unit circle, okay? But what's nice about this is, so far we're only talking about points on the unit circle, but this is actually true no matter what. Okay, because if you have an angle theta, you can always associate it with the point on the unit circle. So we don't really have to worry about that tiny detail, just totally forget about it. Just know that if theta puts you in the second quadrant, then only the sine and cosecant are positive. Okay? If theta puts you in the third quadrant, only the tangent and cotangent are positive. If theta puts you in the fourth quadrant, no matter what theta is, no matter what else is going on, if theta puts you in quadrant 4, then only the cosine and secant are positive. Okay? Just keep that in mind. And again, memorizing this, I really don't recommend it. Just keep in mind what's positive where and which trig functions correspond to which coordinates. Okay? So let's do some quick examples here. So example 1, do we have room down here? I don't believe we do. Well, yeah, kind of. Okay. Okay, so example 1. Let's see, cosine of theta is positive and cosecant of theta is negative. Okay, so let's say that. Which quadrant which quadrant is theta in? Question mark. Okay. So which quadrant is theta in? So we don't really have to capitalize it if it's by itself, whatever. So which quadrant is theta in? Well, cosine of theta is positive. Where's the cosine of theta positive? So let's totally forget about this. Okay, let's just erase this. So it might seem kind of confusing, kind of messy when we talk about all this stuff up here, but let's talk about how to work through a problem like this. So let's draw an x and y axis here. So cosine of theta is positive. Where does that happen? Well, remember, cosine of theta corresponds to the x-coordinate. Where is the x-coordinate positive? The x-coordinate is positive to the right of the y-axis, which means here or here, quadrant 1 or quadrant 4. Okay, so when we answer questions like this, what we say is, okay, cosine of theta is greater than 0 in quadrant 1 and quadrant 4. Okay, so we'll zoom in a bit here. So first of all, cosine of theta is greater than 0 in quadrant 1 and quadrant 4 because, again, cosine of theta corresponds to the x-coordinate, and the x-coordinate is positive if you're to the right of the y-axis, and if you're to the right of the y-axis, then you're in quadrant 1 or quadrant 4. Okay? Or you're on the x-axis, but that's not going to happen because we're asked what quadrant is theta in. It's not going to be a trick question, you know, nothing like that. And also cosecant is negative. Okay, so cosecant is negative. Where does that happen? Well, remember cosecant of theta. So let's come over here. Cosecant of theta is 1 over sine of theta. Okay, so remember cosecant of theta and the sine, sin, sine of theta have the same SIGN sign. So they're either positive together or negative together. So cosecant of theta is negative. That's the exact same thing as saying that sine of theta is negative. Okay, and where does that happen? Well, so since we were asked in terms of cosecant, let's answer in terms of cosecant. So cosecant of theta is less than 0 in which two quadrants? Well, remember cosecant is negative when the sine of theta is negative, and that happens if we're, so since the sine of theta corresponds to the y-coordinate, okay, then the sine of theta is going to be negative if the y-coordinate is negative. Where is the y-coordinate negative? If we're below the x-axis. So in quadrant 3 and quadrant 4. Okay, so again, cosecant of theta is 1 over the sine of theta. The sine of theta corresponds to the y-coordinate, okay? And the y-coordinate is negative if we're below the x-axis. And if we're below the x-axis, then we're in quadrant 3 or quadrant 4. Or we're on the bottom half of the y-axis, but that's not going to happen. It's not a trick question. So either quadrant 3 or quadrant 4. So then which quadrant must we be in? Well, cosine theta positive means we're in 1 or 4. Cosecant of theta is negative means we're in 3 or 4. So 1 or 4, 3 or 4. So we have to be in quadrant 4. Okay, so then the answer is quadrant 4. Okay, again, because in quadrant 4, cosine is positive and cosecant is negative. And that's the only quadrant where that's true. Okay? All right, so that's example 1. Let's do example 2. So let's erase all this and we'll give ourselves more room to write. So example 2 is going to be kind of the same thing, but it's good to see a couple examples just to kind of get a feel for how to work through it and how to think about it. So example 2, and then that'll be it for this video. Example 2, let's see, tangent of theta is negative and secant of theta is negative. Which quadrant is theta in? Okay, which quadrant is theta in? So let's do the same thing we did before. So let's just draw ourselves a little xy plane here. So we'll just do it right here. Okay, so x-axis, y-axis. So remember, tangent of theta, well, that one's the kind of tricky one, right? So tangent of theta is going to be negative when the sine and the cosine have opposite signs. Or just remember that all students take calculus, okay? All students take calculus, so T take tangent, all sine and cosecant, tangent and cotangent, cosine and secant. So tangent is positive in quadrant 3, okay? And it's also positive in quadrant 1, because everything's positive in quadrant 1. So tangent is positive in these two quadrants, and tangent's negative in these two quadrants, okay? Or if you don't like that, if you don't want to think about that ASTC thing, all students take calculus, what you could do is just think, okay, tangent of theta Remember, tangent of theta, let's answer in a different color. Tangent of theta is the sine of theta over the cosine of theta. Okay. So this is the y-coordinate divided by the x-coordinate. So the tangent is negative when the x and y coordinates have, when one of them is positive and the other one is negative. Okay. So when one of the x and y coordinates is positive and the other one is negative, then tangent will be negative, because you'll have negative divided by positive or the other way around. Okay, so in other words, if tangent of theta is the sine divided by the cosine, so if one of these guys is positive and the other is negative, then tangent must be negative. So where does that happen? Well, again, y-coordinate, x-coordinate. So where is one of them positive and the other negative? Well, positive, positive, negative, positive, negative, negative, positive, negative. So one of them is positive and the other is negative only in quadrants 2 and 4. Okay, so a couple different ways to think about it, but no matter how you think about it, you get the conclusion that tangent of theta is negative in quadrant 2 and quadrant 4. Okay. So if it seems like kind of a lot to keep straight, kind of a lot to think about, the more you do it, like with a lot of things in trig, the more you do it, the more you practice, the more quickly it'll come to you, and really it'll be almost automatic after a while. So as long as you practice enough, often enough and hard enough. So that's for tangent of theta. What about the secant of theta? Well, the secant's a little bit easier to deal with. So remember, the secant of theta is just 1 over the cosine of theta. Remember, cosine is the x-coordinate, so wherever the x-coordinate is negative, okay, wherever the x-coordinate is negative, that's where the secant will be negative. Where is the x-coordinate negative? Okay, so let's write that down first. So secant of theta is less than 0 in which quadrants? Well, the secant of theta is negative wherever the x-coordinate is negative, because secant of theta is 1 over the cosine of theta. Cosine of theta really does correspond to the x-coordinate. Okay? So if the x-coordinate is negative, then the cosine is negative. Then 1 divided by negative is negative, so that's why the secant is also negative. So the secant is negative when the x-coordinate is negative. That happens in quadrant 2 and quadrant 3. Okay, only those two. So secant of theta is negative in quadrant 2 and quadrant 3. Okay. So here's what's going on here. So tangent of theta is negative. That means we're in quadrant 2 or 4. Secant of theta is negative. That means we're in quadrant 2 or 3. Okay. So since we're in 2 or 4 and we're in 2 or 3, then we have to be in 2. Okay. So then the answer to this question is, which quadrant is theta in? Theta is in quadrant 2. Okay. And that's it for example 2. So I took a long time to explain example 1 and example 2, but that's just because I wanted to talk about the details and a couple different ways of thinking about it, so that hopefully if one way doesn't work for you, then hopefully the other way will. But there are some more complicated problems that arise in trig that we'll talk about later on, where it really does help to be able to do things like this pretty quickly. Okay, so we'll talk about that a little more when we get to it. But again, just want to point out that it might seem kind of complicated, but it's really not that bad of a topic. Just what you got to keep in mind is which coordinates are positive in which quadrants, and just know that cosine corresponds to the x-coordinate and sine corresponds to the y-coordinate. So that's it for sines, SIG, and sines of trig functions in the quadrants.